This is Abdurrahman Khaled and I will be explaining the VGA controller module. Hello, we are the Ghosts team, and for our digital system design course project, we created the Snake game using Verilog VHDL coding language and the Altera board. We used it along with a VGA cable and display in order to simulate the Snake game. The rules for the game are very simple. The player controls a snake in a 2D array. The player can move the snake in any of the 4 possible directions, and the goal is to try and to eat apples. When the snake eats an apple, it increases in length, but if it hits itself or a wall, the game is over. And now to demonstrate the game, we will play it.
Okay, let's see now how this game works. First of all, let's run it. Now I'm controlling the directions. I'm trying to get an apple. So the size increases by 2. I'm go down. So now I went over myself, so I'm died. So I'll start it again. Here. I'll go up, down, up, left. I hit a wall. I died again. Third time. The score is displayed here over the VGA, over the Altera. I died again. So this is how the game works.
To display our game, we created a module in Verilog called the VGA controller. What that module does is that it defines the limits of our screen, which is 640 by 480 pixels. That module is also responsible for all the shapes you see here. It more or less defines all the edges and all the colors.
Khalid, and I will demonstrate the clock generation module and the random apple generation module. First, we have the clock generation module, which is responsible for generating the VGA clock, which is a clock of a speed of 25 megahertz, which is responsible for displaying the content of the screen. And we have another clock, which is the update clock, which is the clock of 12.5 megahertz, which is responsible for displaying the movement of the snake on the screen. And then the second module, which is the random apple generation module, generates 2 random variables that are x and y, which are the coordinates of the apple to be placed on the screen. The x coordinate is generated according to the VGA clock, while the y coordinate is generated according to the update clock. That's all.
Hello everyone, my name is Sahir Safat. Today I'm going to talk about the Apple module. It's simply called the random Apple generator, and it displays and takes the x and y coordinates from the random Apple generators, and it displays it inside on the screen, inside the edges, at a random position, and also outputs Boolean to any other module that calls it. More likely it will be the Snake module, to display the apple in a red color. Thank you so much.
This is Mahmoud Salem, and my part of this project was to mapping the snake on the screen. Our module snake body makes the snake consist of 2 parts. The first part is the snake head, and the second part is the snake body. The snake head is 1 block of size 10 by 10. When you start the game, the snake always appears at the position of 300 and 300 x and y coordinates. Going to the snake body consists of 31 blocks of size 10 by 10. At the beginning of the game, the 31 blocks is hidden in the back portion of the screen. Whenever you eat an apple, a part of the tail is appeared. 2 parts of the tail appeared on the screen. And to make the snake visually move in on the screen, we delete the last part of the tail and create a new head in the direction of the new movement, like this. The last, and we could hold from this. The last tail is removed and a new head is created. We take the four inputs and the pause and or hold button from the controller module.
I will demonstrate the two modules today. The controller module, which is responsible for the inputs from the Altera board, the four active low buttons here, the right and left, and the up and down for the movement of the snake. Okay, I will buy them. Okay, and they are active low buttons, and the other module, which is the snake, which is the main module of the game. It draws the color on the screen, responsible for drawing the apple and the snake and the borders. And when the game is over, it draws a red color screen here. And it calls every other module.
Mursi, and I'm gonna illustrate the part of the collision in the game. Another module called collision. This module is responsible for two purposes. The first one is to display the score on this LED on the board. The score starts with 0 when you are playing the game as a first. Then each apple, the score increases by 2, 4, 6, 8, 10, and so on. The second purpose for collision module, it handles the collision that happens in this screen. The snake may hit a wall, the snake may hit himself, the snake may eat an apple. So if the snake eats an apple, it increases the size by 2. If the snake hits himself, he dies. If the snake hits one of these borders, he also dies. And assign it to use it in another module.